Hello everyone, this is Dr. Caleb Chen again, and today we'll be talking about central limit theorem, which is about chapter 8 of the textbook, and is part of the sampling methods chapter. Well, the central limit theorem is one of the most important theories in statistics. The understanding and the ability to assume what the central limit theorem is applicable would allow us to approximate probability, and it has wide applications in the quality management. As you can imagine, it would be in the manufacturing sector and also in subsector too. So to begin with, we're going to assume that there's a population that has 5 values. Well, maybe there are 5 students, but each given, say, the some money, $2, $3, $4, $5, $6. You can also pretend that what those are thousands of dollars or even millions of dollars, but for our application, for our discussion, what that will make simple. So the population N is 5, there are 5 counts. Well, we are going to be taking samples of 2. So how many possible samples would there be? You can have, say, 2 and 3 being one sample, I guess. So we have the samples, and let's list them. So the 2 and 3 would be one sample. 2 and 4, 2 and 5, 2 and 6. So there will be 5 of them, and then we can have what say 3 and 4, 3 and 5, 3 and 6, and we can start with 4, 4 and 5, 4 and 6, and the last one will be 5 and 6. I don't think we have left out anything, so there would be the 10 possible samples. And in fact, what we've done before, in this case, well, because the order doesn't make a difference, is the combination equation C5 3 or 2. I'm sorry, C5 2. We're taking 2 at a time, and the way to calculate that is what we have 5 factorial divided by 2 factorial, and 5 minus 2 factorial 3. So that would be 5 times 4 times 3, 2, 1. Divided by 2 times 1 times 3, 2, 1. So we cross this out, and 2, 2. So that would be 10, and that explains why we have 10 here. Now, each of this sample, we can take and calculate an X bar value. So 2 and 3 would be 5 divided by 2, that would be 2.5. 2 and 4 is 6 divided by 2, we have an X bar value of, say, 3, and so on and so forth. We have all these X bar values that came out of the samples, and there are 10 of them, and as such we immediately have the sampling distribution of X bar, or sample means. So in this example we only have 10, but what if, say, the population size is 500 and the N, let's say, is 30. So how many possible samples would there be? The same equation would be used. C 500 and the 30, that would give us an infinite number of samples, and each sample would allow us to calculate an X bar, and as such there would be an infinite number of X bar values. The central limit theorem basically is saying that if the sample size is large enough, then the sampling distribution of the sample mean would also be normally distributed. So that might take the shape, say, that when N is large enough, when N is equal to, say, 30 or more, that it would be considered large enough out of a population size that is much bigger than 5, of course. Then we are looking at a normal distribution of the sample means. So we are plotting the X bar values, and imagine that what they are, there's a histogram showing all the possible X bar values from one point to another, but they're lining up and forming a bell-shaped curve. Once this concept is established, we would be able to tell or answer the question, such as what's the probability that X bar is greater than or equal to, say, 3.5. So going to this distribution, we know that the mean, according to the central limit theorem, is going to be the mean of the population mean. So in this case, actually, but the population mean is equal to, I believe it's going to be 4. So the 2 plus 3 plus 4 plus 5 plus 6, that would be the 20 divided by 4. No, let's say that would be the 9 plus 11, 20. That's right, 20 divided by 5, not 4, is equal to 4. So 4 is the mean of the population, which is also the same as the mean of the sampling distribution of the sample mean. So this parameter has to be established. So mu of x bar has to be, mu of x bar is the same as mu of the population when the central limit theorem is applicable. And also the standard deviation, well, because it's a distribution that has a standard deviation, which is sigma of x bar, and sigma of x bar is equal to sigma divided by square root of n. So keep these two parameters in mind as we do further calculations.